A DC current passes through a rectangular wire loop, OPQR, placed between two pole pieces of a magnet as shown below. Let's have a look at how the scenario is like. We've got there two magnets, and remember, we are talking about magnets, so therefore we are now talking about poles. That's why we've got north and we've got south. No more positive and negative, because this is no more about charges, but this is about magnetic field, right? And then from there we've got that rectangular wire loop, okay, right? And there you go. And can you see you've got something on top there to show that there is going to be motion of this wire here. And what is it that you're going to have? When you have something like this, it shows that, you know, this wire is turned anti-clockwise. But these arrows here are telling us about the direction of current. So please be aware of what is it that is being asked. All right, let's have a look at what the question is about. Which two segments of the loop will experience an electromagnetic force when the loop is in the position above, right? OP and PQ, let's have a look. OP, PQ, all right? QR and RO, QR and RO, okay? Right, let's have a look. OP and QR, OP and QR, okay? RO and OP, RO and OP, right? Now guys, the minute you talk about rotation, you can see that, you know, this is the shape. And if it is moving either clockwise or anti-clockwise, that is how it's going to move, yeah? And what is important is that this is the application, remember, of our either Fleming's right-hand motor rule or left-hand motor rule, all right? Fleming's dynamo rule, to be more specific. But this is not specified. But what is important is that there will be force, definitely. Now, in this case, we know that the direction of current and the magnetic field plays a very important role when it comes to how this is going to affect the movement of an object here, or of the wire, to be more specific. And we find that there will be more of that is going to happen if there is more of the disturbance of this magnetic field. And let's have a look at what is happening here, especially in the direction. Look at the OP, and then you look at RQ. And can you see that in this case, the direction is that way, and the magnetic field is going that way. So there is more of, you know, some sort of a disturbance in this case. So in this case, and then what about here, PQ and QR? You know, it's like, you know, they are going in the same direction, so there's not that much of a disturbance, okay? So because of that, the movement will be more with regard to these sides. That's where we are going to get that. So which option was given? This is OP and QR. Really, it doesn't make any sense when you even take PQ and now you take the other one on the side. No. It could have been then you take either these two or these two. But it depends really on how the current is like. So if it is going that way and this one is at right angle to it, then definitely that's where you're going to get more of that force, all right? Very important. Okay, so this is our answer.